Okay, so what do you guys have questions on? I have the 6B up here, the electrical system. Are there questions on this one? Lois, did you have a question on this stuff?
I thought the first page it says which of the components allow the electrical signal to travel from the atria to the ventricles through the fibrous skeletal.
That's a good question.
And
Okay,
then
let's
the
go
other
to
one
that.
is the next one under it, which components is responsible for the actual electrical excitation of the ventricle, cardiac.
Okay, both good questions.
Page 7. Okay.
And then there on 8,
Don't go to the questions. Basically, the whole section. The whole section. Like power through the whole.
Okay, so here's the electrical system up here, and let's just go through it. You know, where does this whole thing start? Here's the electrical system. Where does this start? Up at the SA node. Okay. And the SA node fires. It's the pacemaker. And what happens when every time the SA node fires?
It'll hit like the ventricle wall.
What happens when the SA node fires? What's the next thing that happens? I mean, what's going on, just functionally speaking? This becomes electrically excited, and then what happens
It
next?
starts the atria and the ventricles to signal time.
No, I mean, I want what's step by step, kind of stuff. What happens to that electrical signal in the SA node? Has to do with gap junctions. That electrical signal spreads from the SA node all throughout the atriomyocardium. So when the SA node fires, it's like simultaneous excitation of all those atriomyocardial cells. And why is that important? Why is it important that they all become excited at once? So they all contract at once. Remember, for a muscle to contract, you first have to electrically excite it. Same with skeletal muscle, smooth muscle, cardiac muscle. And what event on the ECG does that just correspond to? That's the P wave. What happens immediately after the P wave? Atria become excited, then they contract. All right, and then as I mentioned, there's a insulating fibrous skeleton that separates the atrium from the ventricles. And that's why the ventricles don't become excited along with the atria. Okay, that allows them to become excited separate from each other. So we have to get that electrical signal from the right atrium, from the atria here, down into the ventricular system. It has to go through this fibrous skeleton. Okay, so how's it going to do that? What's the first step here? The AV node becomes excited. Okay. And what's the next series? What's the next structure it goes into? The AV bundle. Okay, atrioventricular bundle. So this is the structure that takes the electrical current from the atria and takes it through that fibrous skeleton into the ventricles. So that's one of the answers to your questions there. The AV bundle. Okay. Then what happens to it? After the AV bundle, what's the next structures? The bundle branches. And what's this structure that the bundle branches are traveling down through? The interventricular septum. Then it goes down here and it reaches, what's this part of the heart called? That's the apex. And those bundle branches at that point branch out and they go all throughout the ventricular myocardium. And what are the structures called at that point? Those are the Purkinje fibers. And it's the Purkinje fibers that actually send that electrical signal and excite the ventricles. When that signal is traveling through the bundle branches, it's insulated within that nerve. It's not firing the ventricles yet. It has to go to the Purkinje fibers to do that. So then all of the ventricles are excited. And what part of the EKG does that correspond to?
QRS.
The QRS complex. And what happens right after the QRS complex? It contracts. Is there one down here as well?
Yeah, the sympathetic, parasympathetic.
That whole go back.
Okay. So here's let's look at some blood pressure homeostasis. You know, blood pressure has to be within a certain range, and why is it important that blood pressure be maintained? Why do we need to maintain a certain level of blood pressure? To make sure that blood is being moved throughout the cardiovascular system. So what happens if it gets too low? Well, that's something that the nervous system wants to know about. And so there are sensory receptors located in what they call the carotid sinuses, I think I've heard somewhere, and also in the aortic arc here. What kind of sensory receptors are those? They're going to detect blood pressure. Baroreceptors. Baro refers to pressure. So blood pressure goes up, these baroreceptors are excited, and what part of the brain is it going to send that information to? The medulla oblongata. And we have a choice. We can activate either the sympathetic or the parasympathetic. And excuse me here, blood pressure went down low. Okay, we're dealing with low blood pressure here. So we don't have enough blood pressure to pump blood throughout the body, something we need to fix, and so we want to increase that blood pressure. So are we going to activate the sympathetic or the parasympathetic system in this case? Sympathetic. And what are we going to do to heart rate? It's going to go up. Are we going to do anything else to it? Increase. What do you call that? Contractility. The force of the heartbeat. So that's going to send more blood out, so that'll help increase blood pressure, get more blood out into the arteries. And what are we doing here? Widespread vasoconstriction throughout the body. You vasoconstrict and that increases blood pressure. And this is the medulla up here. And so that sensory information comes in, and in that case, we're going to stimulate the cardioacceleratory center. And you can see here in the medulla, that medulla sends a neuron down to the thoracic spinal cord, and it stimulates the sympathetic nervous system, which is going to innervate the heart. Here's the preganglionic neuron, which synapses in the sympathetic trunk ganglia. Remember that thing? Then it synapses with the postganglionic neuron, and it comes down there and it fires on SA node, causes heart rate to go up. And what are these fibers doing down there? They're increasing contractility, stimulating the ventricles down there. So let me kind of give you some stuff that I want you to be able to know here, because you'll get this on the exam. I want you to be able to tell here where the two main phases of the cardiac cycle are, and what do we call those two main phases of the cardiac cycle? What's this one called right there? What's this stage called right there? That's ventricular systole. So that's one stage of the cardiac cycle. And what's this next stage called? Ventricular filling. You have to know those two terms, and you have to be able to put them correctly on this chart.
It's just the blue.
This is all ventricular filling right here, and then this is ventricular systole. Ventricular filling, ventricular systole. I wish they would have made this a little bit different, like starting here and then just continue on out that way. So let's look at ventricular filling right here. And we have two stages of ventricular filling. We have this stage, and we have this stage. What's going on in this part right here? What is this called?
Passive.
This is passive filling. So by the way, let's look at these variables that we have here. Here's our ECG. Here's our blood pressure, which I'm not going to test you guys necessarily on that. And then here's the ventricular volume. So why is this called ventricular filling? Because we're going from the lowest volume in the ventricles to the maximum volume. Okay, so we're filling up the ventricle. And how does most of this, 80% of this, occur? Passively. So blood is moving. There's something I can put this on. I want to prop it up on something so you guys can.
I'm not going to ban that.
Recognize that, huh? So first of all, let's orient ourselves. Right side, left side. So what's this? Right atrium, right ventricle, left atrium, left ventricle. So ventricular filling, blood is moving from the atria, from the right and the left atria, into the ventricles. And 80% of that is occurring passively. Okay, so what does that mean passively? What's not happening?
No contraction.
There's no contraction of the atria yet. Blood is just flowing from an area of higher pressure to lower pressure. And 80% of the ventricles, 80% of the blood in the ventricles occurs during that period. And then what happens in this last little blip? All this blood is flowing passively. Atrial contraction. So the atria contract. And they shoot that last little bit of blood down into the ventricles. And so now you have, the ventricles are filled with blood. And how do you know that the atria just contracted?
P-wave.
P-wave. Okay, this is when the atria become excited and they contract immediately after that. Okay, so that's important to know to be able to put those things together there.
So like a P-wave, like I'm not so sure, but like a P-wave breaks, then it's okay, kind of, right?
Yeah, so if the
80% of it got through, and
Yeah, so what happens if you look at an ECG and you're missing a P wave? It's just not there. The QRS, the T wave's there, but the P wave just isn't there. Then what does that indicate to you? That the SA node is non-functional because you're not getting that P wave. But can you live like that?
Yes.
You can. And the reason is because most of the blood that fills up the ventricles doesn't require that contraction. So you're still shuffling enough blood through the system. So we just went from what we call end systolic volume to end diastolic volume. Those are two terms that I want you guys to know too. The lowest volume of the ventricles, end systolic. The highest, end diastolic. We just got done relaxing diastole. That's the volume at the end of relaxation. Now that we get into this next phase, we just took blood from the atria, we just filled the ventricles, and naturally, what do we want to do next? Sierra, naturally, what do we want to do next here?
After,
So we just had blood that moved from the atria into the ventricles.
that contracts it.
We want the ventricles to contract. Okay. So we go into ventricular systole. So how do you know that the ventricles are contracting here? Give me the best, surest way to know that the ventricles are contracting.
The volume dropping.
Well, I guess there's a lot of few. But the most direct way that I was looking at is this QRS complex here. The ventricles become excited and they contract shortly after that. And then you have this sustained contraction here until you get to the T wave. And what happens? They contract, the pressure goes way up, higher than in the aorta, so that causes the blood to go from the ventricles up to the aorta and up through the pulmonary trunk. Okay. And then the ventricles relax, that blood slaps back on there, causes the second heart sound. So yeah, when those ventricles contract, they shoot blood up there, but they also snap these semilunar valves back, and that's the first heart sound. Then the blood goes up, the pressure gets lower, it slaps back on those semilunar valves, and that's the second heart sound. And then the last thing here, important thing I want you to know, is this value right here, stroke volume. Okay. You take the highest amount of blood and the lowest amount of blood, you subtract the two, and that gives you stroke volume. And what is stroke volume telling you? What is this value telling you? The amount of blood that's ejected from each ventricle. Almost done. What else?
For each heartbeat.
For each heartbeat. And that's an important value to know. During exercise, when we want to increase cardiac output, what are a couple ways that we can do it? We can increase contractility, squeeze more blood out, drop that down. We can modify that stroke volume. You guys feeling better about that whole thing? Then we have cardiac output, how much blood is going out of each ventricle per minute. And, this is at rest, 5 liters per minute. This is heavy exercise, 5 times that much is coming out. The cardiac output is 5 times higher. So there's more blood coming out. We send that to different places in the body. So how can we increase cardiac output? Well, there's a couple ways. We increase heart rate, or we increase stroke volume. Okay. So if we want to increase heart rate, what do? Activate the sympathetic nervous system. Comes down, synapses on the SA node, increases heart rate.